from California. It is 9 o'clock here in Los Angeles. I am Francis Savignan, the founder and CEO. Welcome to Race Industry Now. With me this morning, we have Judy Keane, the co-founder of EPARTRADE. Good morning, Judy.
Good morning.
Very good. How are you today?
Good, good. I'm excited about today and about next week.
Excellent. And then we have Jeff Hammond with us today, who is going to be hosting our webinar. So Jeff, I have a question for you. That question came up last week. Do you know how many tech webinar have we produced since the first one back in July last year with John Causey and Lake Speed?
Wow. You got me at a loss right there. I know it's a lot. And the other thing is, let me slow down 1 second. Good morning, Francis. Good morning, Miss Judy. How are you doing today?
Morning,
I'm glad to hear everybody's going well, but I really don't. I was actually looking at what Brad Gilley and I had done so far this year. And I mean, it's pretty easy to figure that out. You go through and say, okay, we're basically headed, we've done 3 months worth of them. And let's just say there's 4 Wednesdays in every month. I mean, I'd be 12 to 14 of these webinars so far, but going back to last year, no, I don't think I've quite got that number down. But because are you including the industry week that we did too?
Yeah, so the question came with Lake Speed, who was on our panel last week, and that was the 4th time we had Lake, and says, hey, Lake, I think you're the #1 panelist, have been there 4 times. So, and he said, how many have you produced so far? So we started to count between the first one when we started EPARTRADE Live Tech Webinars and Online Race Industry Week, and this new series called Race Industry Now. So the grand total is 91. This is the 92nd one. So we decided to put them all together in one place. So now you go to epartrade.com, you click on the Race Industry Now page, and you'll have the 91 previous webinars. You have, webinars on suspension, on engine parts. You have interviews with industry leaders like Roger Penske, Chip Ganassi, crew chiefs, etc. So they're all in one place. So enjoy the webinar today. It's being recorded. It will be featured also on the platform. We also have all these webinars on podcast, and so we just decided to put them all together in one place and put numbers on it. So this is episode 92. Very good.
Hey, real quick, while you're bringing this up, I was actually talking to a potential client of y'all's the other week, and I think I brought it up to Judy, and was explaining to them that how you've been able to allow different companies to come and to talk about their product and how important that is. And I also mentioned the fact, excuse me, that, you do have a place where this is being, cataloged. And so, you can check out your competition, or you can look at what they've already done, and you can learn from all of these other great companies that went ahead of them of how to do it. And I think that's what's important, is that through all of this, not only are people being informed on great products, they're learning how to showcase their product. I mean, you may be on it one time, just like Lake Speed. I'm sure if he looked at the first webinar he did and the last one he did, he will probably notice a marked improvement about how he did about, presenting it, talking about the product that he is focusing on that particular day. So I think every company that gets involved here, they grow exponentially, not just as far as sharing their product line, but how they present that product line to each and every time they come on the show. So I think it's something that, as you're listening to this right now, folks, my point is, don't be afraid to raise your hand and say, hey, I want to do one of these, because you're afraid you'll mess up. And the only way you're going to get better is get in, do it, and go back and watch it. Because every time I do something, I watch myself back and I say, I think I suck. I got to work on it.
No, you're brilliant, Jeff. You're brilliant. So thank you very much. I'm getting a signal from our producer, Reed Keneski, who is going to be bringing our presenter. So today we have the privilege of having PAGID, who is going to be presenting a tech webinar on racing brakes. So Jeff Hammond, you on for the next hour, and Judy and I will see you in about 55 minutes or so. So I think we're getting Jim, camera is on. We're getting, good morning, Jim, Ian, excellent, Mark is on. Thank you very much. Have a great webinar. We'll see you soon.
Enjoy.
All right. Thank you very much, Francis and Judy. Good morning, gentlemen. How are we doing?
Good,
Doing
Jeff.
great.
How are you?
Oh, just glad to see y'all. I mean, really are, and excited about seeing you today because number one, I'm talking to three gentlemen here that are you're knowledgeable. I mean, I'm very impressed with what all of three of you have accomplished throughout your careers, as far as from being mechanics to engineers, to crew chiefs, to drivers. You understand the product you're not only talking about, but you're talking about something that is so important to every racer, no matter what form it is. And it's how do you slow this sun gun down when it gets to going too fast, make it go around the corner, or even just stop to where you can turn around and go back the other way. So I'm really interested to see how you can educate me as well as our viewers right now about not only your great product, but the experience you bring to the table. So who would like to lead out here? Would you like to lead out, sir?
Sure, I can do this. I can start up, I guess. I mean, for one thing, this is really about education more than product sales. So it's
Right.
not going to be all about us. And I'm a big fan of every type of motorsports. I like cars, motorcycles, dirt track, asphalt, sports car, you name it. So almost everything that's in here is going to apply to across the board. So I just need to figure out how to share my screen here, and I'll get started. There we go. All right. Is that looking okay for everyone?
That looks good right now.
Okay. Like I said, to me, it's really big, really important that we not become overly focused on just what we do, and just sort of look for the big picture out of this whole deal. There we go. All right, so just some basics, big system physics to start here. Porsche 911 GT3 RS. It's a pretty quick car, pretty light car actually. And the amount of energy that's involved in stopping the car from top speed is really substantially more than the car produces, and that's not something to ignore. It's about 2,500 horsepower, and it's exerted in a total of 7 seconds. Now, to put that in sort of some reference that other people that don't necessarily use just horsepower to measure power or energy is, think of boiling 3.5 gallons of water in 7 seconds in the microwave.
Okay.
That's comparable to what it does, in a single stop. And the thing about it is the brake system on these cars can do it time and time again. We get the car down to 0, accelerate back up to top speed, you can do it again. It's not a one-time deal. It's got to be consistent. It's got to be reliable. And for the most part, it's predictable. As long as it's been maintained well, it's going to do this all day long. The energy involved in this whole process, 90% of it is dispensed by the rotor. 10% of the pad, 10% of the heat and energy that gets put into the system goes into the brake pad itself, which, I mean, just looking at the image here, you can see there's not a whole lot of cooling surface. So the disc has to do almost all the work. It's all done through convection by air blowing through it, and radiation, where literally if you stand next to the car for Martinsville, for example, you pretty much get a suntan just sitting there during a pit stop. It's putting out so much heat. A quick animation of the pad. Oops, sorry about that. Quick animation of the pad kind of going through its surface, scanning, sliding across a stationary disc, opposite of what reality is. I'm going to fast forward to the 27-second mark because it just kind of points out some of the stuff here. The spread of the thermal energy across here, this is about 785 degrees in the center here. Mm-hmm. And it's still only about 300 Fahrenheit or about 150 Celsius out here at the tip. and 700C, 800C almost. So 1400 Fahrenheit and 300 Fahrenheit across roughly 1.5 inches. So the amount of thermal stress that's involved in that is tremendous. You've got this part of the disc trying to grow as fast as it can, and this part of the disc is actually trying to stay its current size, shrink. And here you can kind of see a little bit about, at the peak, this blue section, because the thermal distribution across the discs, this red section is growing dramatically. So this part is trying to grow and expand, but all this stuff down, all the sections down below it, like where the red is shown, that's trying to stay the same size. So basically you've got the middle of the disc trying to expand, the inside edge of the disc is trying to shrink. And if you ever seen a brake disc crack, it's almost always in this location.
Right.
And it's because of that thermal distribution across the disc itself. So when people try to rush the bedding process, this becomes the point where the stresses become greatest. So again, this comes down to pre-bedding or slow bedding a new disc. Once it's been bedded, it becomes a lot less critical, only because the grain structure in the disc itself has aligned itself nicely.
All right, let's stop right there since you're on this part of the subject as far as bedding is concerned.
Sure.
Is it better to buy rotors and pads that are pre-bedded as a match set? Or if you can't afford to do that, what is the process for proper bedding? Because again, you use the Porsche as an example. We're going to go wide open and slam on the brake. What is a proper way of doing that?
Well, I mean, to me, pre-bedding discs, because quite often the pads will be replaced before the disc will. Okay. So you can't always do match sets. If you're pro racing, NASCAR, short track, everything is thrown out after the race, admittedly, or after Sebring or Daytona, yes. But the average track day guy may go 3 sets of pads to a set of discs or more, potentially. So pre-bedding it is always beneficial, in my opinion, because it's brought up to temperature in a controlled atmosphere, controlled situation, and getting everything pre-bedded together is the optimal solution. But you can't always do that, simply put. If you figure out the cost of the race car versus track time, it's always worth it on a cost per mile or dollar hour basis to pre-bed on a dyno, no question about it. Between the wear and tear on the car and the cost of the track time, it's an easy math. If you're a track day guy, bedding it is just a simple solution or program of step by step. You don't want to jump in whole hog and on the first braking zone. You want to bring everything up to temperature over a course of 2 or 3 laps. Sort of like buying new tires or starting on the track at 8 a.m. when the track's cold, the tires are cold, and the driver's cold. You never jump in at 10 tenths. You start out at 8 tenths, then you get comfortable, and then you go to 9, 9.5, and then 10, and off you go. And that's the same thing with the brake system. If you start off with everything brand new on the car, new discs, new pads, I would say on the average track, it'll probably take 3 to 5 laps to get everything up to temperature and everything bedded in. So, I always say start if you expect to break at the 3 marker, for example, on a road course, start out on the first lap at the 6, then move it down to the 5, then move it down to the 4, and then down to the 3, and everything will just come up. And by the time you get close to the typical start, breaking point, it's all going to be happy. It's all going to be working well. And typically the driver will feel it as it comes up. Does that explain it fairly well?
Yeah, it does. But I'm going to go one step further.
Sure.
When you get through bringing this thing up to temperature, you know, and everybody talks about proper, operating temperatures. When to have a fan turned on, when not to have the fan turned on, you to help cool your brakes. Is there a thing that in y'all's mind that's better than another?
I mean, for road racing,
Let's say for Martinsville, for example, you know, you bring it, you get it high. I mean, how much is when you throw the fan to it? Is it shock to drop the temperature real quick, or what do you think on that?
No, convection is such a small part of, because the wheel speed at Martinsville, for example, is so low relative to a super speedway. It's not really getting that much airflow across the disc itself, and ambient air doesn't have a huge impact on the cooling. A lot of people talk about, well, it's a cold day versus a hot day. Well, your delta T, your difference between ambient and operating temperature, is so big. It's, you know, your difference between 75 Fahrenheit and 1300 Fahrenheit on the disc versus 90 Fahrenheit and 1300 on the disc is so, it doesn't change the percentages much at all. So ambient temperature really doesn't have a lot to do with it. It's really more about track temp and grip. So a rainy day where there's no grip is definitely going to cause everything to run cooler, but it's really about the grip levels available on any given day. And as far as cooling air, trying to keep things cool, I mean, on the stock cars, like at Martinsville, the biggest thing to me is always keeping the caliper cool, because you absolutely have to keep the brake fluid temps down. So blowing air on the caliper, through the caliper, keeping the pad temperature within range is the critical point. And anything else you can do to, I know some guys have used blowers to ostensibly cool the brakes, but they actually aim it at the bead of the tire, or the shoulder of the tire to keep the tire cooler. In reality, just air moving through the area is going to help cool everything anyway. So it's not that critical, I don't think.
Okay. Hey, we got a couple questions here, and I want to bring Jim in as well as Mark, and get them involved here also in our discussion. But and Mark, in your situation, when you're, you know, betting brakes from a driver's standpoint, do you feel the change as it gets hotter and hotter as far as the grip levels, you know, concerned? And you know, Jim, overall, I mean, as far as the ability, when you get to where people are swapping brakes around, say, for example, we have one guy's wondering, you know, well, I swap brakes, you know, do you recommend, you know, cleaning the rotors, you know, when you swap brakes? And if so, what is there a method to it? I mean, is there something you recommend, you know, to keep the rotor cleaner? You know, how do you go about doing it? Do you sand the brake pad that's going in? You know, is there a process part of that also?
Yeah, we'll have Mark start. How about you go first, Mark?
Sure, no problem. Those are all really good questions, Jeff. I think, you know, from a driver point of view, and Ian touched on this quite a bit. The first process really is you have two things that you're looking for when you're betting: temperature, bringing the temperature up somewhat slowly, but also getting all these rotors that are used that you're putting new pads on. They need to match up to the surface. So you have all these grooves in these surfaces. And so if you can imagine just rubbing your hand on something super smooth or something grooved, you're not getting all of that pressure on until you full grip, until you can really kind of grip it together. So you need to bring the pads up to temperature somewhat slowly. And it may take 2 to 3 laps to do this, depending on the track, depending on the compound, and you know, what brake temperature that the rotors are working best at. But once those grooves start to take shape and the pad starts to conform to the rotor, you actually feel that. You feel an increase in the ability of stopping power. It feels more smooth, comfortable. You'll get more grip. But what you don't want to do is go out and expect, and with cool brake pads and cool brake rotors, when you're trying to do the betting process and really applying a lot of brake pressure, all you're doing is trying to force that process. And you can get in a situation where you start to glaze the pads and you're actually burning the material rather than letting it bed in. And the problem with that is you never really get a good pedal feel after that. It's you can have, you know, pads with a lot of life, what looks like on them, but they're not really doing anything. But
they've got no grip.
Yeah, they've got no grip. It's like putting sticker tires on that have none of the stick. And unfortunately, you know, that's the importance of the bedding process. And to cover something that was talked about earlier, you know, depending on whether you pre-bed pads or not, you still have to build that temperature relatively slowly, even though it may be bedded. If you take a bedded pad and you put it on a used rotor, because typically you run the pads 2 or 3 times on the same set of rotors, it's not perfectly matched. So you still have to do somewhat of a bedding process, but typically it goes fairly quickly. And it just comes down to, do you have the time and ability to do it? When I race in Trans Am, we always had pre-bedded pads, and you could probably bed your set of pads in on an outlap. You can get really close on an outlap. In GT cars and GTD and IMSA, typically we use a test day at the end of the day, and we'll cycle 3 or 4 sets of pads through so that we have 3 or 4 sets of bedded pads in the trailer already. And that's just how you decide you're going to prepare for an event.
Yeah, so Jeff, in regards to the maintenance or kind of the bedding process, and what do you do? So you're changing pads, right? So the track day customer, let's talk about that guy. You know, they're going to be on the track. They're going to want to update their pads. From a preparation point of view, what's important is you need a clean surface. So if you've got a used rotor and they want to put on new pads, what we recommend is a little bit of a scuff. We say scuff that rotor up a little bit, take that shine off. You can use some light sandpaper, some Scotch-Brite we like to use in the industry. Take that surface off because you want to rebuild that surface layer. We call it the friction couple. We want to rebuild that. And by doing that, you ensure that you've now got a clean pad with a used rotor with some open metal surfaces, and you're going to rebond it back together. That is the bedding process you're going to do on track. There's a lot of stories out there. There's a lot of philosophies. Guys got this idea in the garage. But from our point of view, you scuff it, it's there. But you also got to make sure that rotor's, you know, is flat, it's straight, you know, its run out characteristics are there. If you've got a wavy rotor and you're on a year of track days, it's really in your best interest to do an upgrade on that rotor as well with the pads. But again, it's like Mark alluded to, even for the track day customers or our professional race teams, it's a 3-to-1 ratio. For most situations, it's 3 sets of pads to 1 set of rotors.
All right, very good. All right, come on, and let's keep going on this education part right here, Ian.
Okay. Just basic physics part 2. The mass of the system is the key, and that accounts for the disc and the pad both. And actually, let me back up, because I just thought of something that Mark had mentioned. Bedding pads in a single lap, like on a Trans Am car. There are some pads that really do work better with being allowed to cool back down after bedding. And there's typically our pads, you can basically, once you get them hot, just run them. It's not going to extend the life of the pad to cool it down. Other brands, I know some drivers will bed them and then literally put them on the shelf overnight to cool down and then put them back on the race car to extend the life. So it depends on the manufacturer to come up with the best solution for that sort of thing. So just while I'm thinking about that, if that's okay. So back where I was going with this, mass is the key. How big, how heavy the disc is, how much pad material you have determines how much energy the system can hold on to until the next straightaway when it gets to cool off. You know, think of it as a bucket. The bucket can only hold a certain amount of water / energy, if you will. If you end up with too much energy for the amount of mass storage that you've got, everything's going to overflow. It's going to become a problem. It's going to create issues that you hadn't expected. And this can be, you can use the exact same system on 2 different racetracks and have 2 completely different results. Tracks that are hard on brakes, Martinsville versus Daytona Super Speedway, you wouldn't run the same brake package because it just needs the energy storage capacity for the short track. And If I remember right, I think the Martinsville discs are like 41 millimeter thick or something crazy, and the pads are up to 32 millimeters thick. So 1.25 inches, and just simply, I think 35 to 40 pound disc.
Yeah. Yep.
I mean, it is a lot of energy capacity having all that mass. And for road race, for a super speedway, you'd have something that weighs a fraction of that, maybe half or even less, most likely. So, you know, energy capacity is what you really need to watch for. As the energy overflows the system, we get into positions where we end up pad fade or brake fluid fade. Pad fade is going to be one of those situations where, for example, years ago, was it USR or Grand Am used to run at Montreal, and the thing at Montreal was it's got a long straightaway, a little kink on the front stretch, and then it ends up using the brakes a bunch going around the back half. So the brakes were good all the way to about the hairpin. When they got to the hairpin, they'd complain about a long pedal. So basically it was building up heat in the system, more and more heat as they went, until it finally got to the saturation point at the hairpin. And what they talked about was a long pedal, pad fade. Long pedal to me is one of those terms. I try to be more specific with my terminology, because a long pedal just means you're having to push harder and farther to get the car to stop. Pumping it up doesn't make a difference. It just doesn't want to do what you want it to do. You know, so usually the driver can tell it's coming because it starts to stink. A little bit of smell, like clutch or brake bedding, if you will. And the only solutions to this are better cooling. Sometimes that works. The homologated cars nowadays, you can't change any of that. Getting a bigger disc, thicker, heavier, different vane configuration, you know, go from a 24 to a 48 vane or 200 plus. Change the brake pad compound. So the one that operates at a higher temperature range will do definitely help this out. ABS systems can make it worse because they just try to do what they're trying to keep the tire at the limit, and doesn't care whether the brakes are fading or not, and drivers tend to stand on it with a 10 pedal when it might need a 7. So all that stuff comes into play. In my experience,
I can certainly attest to that, Ian.
Yeah.
I mean, having raced both non-ABS cars and ABS cars, to really get the most out of an ABS GT car, you are using the brake far more in the amount of brake pressure and far later. And you know, yeah, the pluses are that the overall brake distance should be shorter because you can carry a much harder brake pressure for longer. The minus is you carry a large amount of brake pressure all the way into the corner, and you use the ABS system. So it really is rough on the brakes. And, you know, typically that's where we could run a 12 or 24-hour race with maybe changing one set of pads. It's kind of necessary to do a pad change with ABS cars just because you're using the brakes so much more.
Exactly. And it doesn't take much difference to resolve an issue like this. At the time we went to a disc that was half a pound heavier than the existing disc, because the engineers always want to run the lightest thing possible. So the next, a different brand weighed half a pound more per corner, and it solved the problem completely. So
okay, well, we're getting some panelist questions here. We need to jump back in and address before we go much further.
sure.
One of the things has to be, you know, we're talking about the mass. Can there be too much mass? You know, will it retain more heat as a detriment on some tracks? You know, what in y'all's opinion is better? You're addressing that right now, but you know, Mark and Jim jump in here too. What, you know, is it better to err on the side of too much mass than trying to do the fine line? We're talking about, you know, like a quarter, half a pound too much per corner.
I mean, I revert back to the true brake engineers with Ian and Jim, but you have to it has to vary based on your need, because you can have too much mass where it doesn't get enough temperature in the rotor. And you can get too much mass where it's just not a performance advantage. And, you know, the bigger the brake rotor, the heavier it is. It may stop really well. It may not, but it may stop really well, but you're also adding more rotating mass to all four corners of the car too. So there's a performance gain and loss with everything. So it really varies on what you're trying to accomplish. It could be as simple, and Jim, you know, or Ian can jump in on this, but it could be as simple as just having the wrong pad compound for, as far as temperature goes, that could really, you know, what temperature range that their optimum, you know, work at optimum level at. And if you're out of that range, then that's where you could be suffering, and it not necessarily rotor size.
Okay, let's jump in here right quick, because you bring that pad situation up. We got a question is there a difference between endurance and sprint pads? And I think, you know, you're trying to address that right now. How do you wind up with the right pad for the right application at your racetrack? I mean, where do you start trying to figure that out? I mean, in NASCAR, we obviously know we go to Martinsville, we need this, but we get ready to run, for example, Atlanta or Charlotte, we don't need that. You know, there's a wide range of, I think, choices for every racer depending on where they are, at least from my experience.
Yeah, so I'd say, for example, within the short track world, the late model world, modified world, even the NASCAR world, right? You got some different compound levels based on friction needs, braking needs. The endurance materials, right, are developed around the road race material or the road race industry. You know, so your track day customers, right? In some cases, you're better off to be conservative and stay with an endurance material because you're going to get some longevity out of it. That customer's going to be happy because he's going to get that 3 to 4 track days out of it. With a sprint material, they may only go 2 track days. And so sometimes within the industry, people will say, oh, well, this is a better pad. Well, as Ian alluded to, you have to, and marked it as well, you have to find the optimal range for your situation. So for example, in the road race track day market, if you're at VIR is not so hard on brakes. You go to COTA, you are going to use that brake pedal up more than you'd ever think. And most people say, well, that's not so, you know, that's so hard on brakes. And you'd be surprised from track to track. Even take Richmond and Martinsville, Jeff, from your experience, Richmond's harder than people think. And, you know, when you have the night races, it's nice because you can watch the glowing rotor. As brake engineers, we're panicking and we're watching the color of the rotor. Is that a good red or is that a bad red? You know, so you really have to be aware of that in what the market is.
Yeah.
A lot of short track guys up in the Northeast, you go from a flat track to a bank track. Obviously on the flat track, you're going to utilize a little bit more brake.
Well, hopefully answers our questions for some of our panelists right now. So let's get back to the brake fluid fade too, because here again, we're bringing in another part of this equation that seems like always rears this ugly head somewhere along the way, especially when you start abusing brakes.
Yep, very definitely. Brake fluid fade is one that I always call a soft pedal because you can pump it up and it comes back. The key is, and this is something Mark mentioned to me not long ago, was pumping up the pedal is also used sometimes when you've got knockback issues. With knockback, you retain the ability to modulate effectively with the brakes, but it just takes a couple of pumps to get it up to where it should be. Fluid fade means you've literally boiled the fluid in the caliper or in a line somewhere, and you're compressing the gas bubble back down to 0 if you can. And that brings the pedal back up. But the key is all you can do at that point is put fresh fluid in the system. You have to clean it out. Some of the older fluids, you could actually see the color change in the fluid as you bled the brakes after a race. You know, bottom line is fluids now are better than they ever have been. Back when I was still a crew chief, there were only a couple options. Now there's a whole bunch of them out there. But the bottom line is you should always have a dry boiling point of 300 Celsius and a wet boiling point minimum should be 200 Celsius. Anything above those numbers is pretty good. I generally focus on the dry boiling point because if you're maintaining the car properly, that's the part that you're going to be approaching more often. If you don't bleed the brakes often enough, then maybe wet boiling point's a bigger item for you, but not necessarily, it shouldn't be. Again, we'll highlight the fact that bleeding the brakes is a really big part of the system. I'm going to throw in a little DOT 3.4.5.1 spec information, because I think there's so much misinformation out there right now. It's tough to say, tough to be correct all the time. There are minimum specs that are defined by DOT. I actually went out and read it's the Federal Motor Vehicle Safety Standard 116 that explains the whole procedure on how to test fluid. And these values that are on the screen are minimums. It has to reach those numbers to fulfill the requirements to be called that. DOT doesn't approve anything. They just give a set of guidelines to follow. So if it meets .3 or .4, for example, it has to have a minimum of 230 C dry boiling point, has to be more than 155 C wet boiling point. The viscosity has to be more than 1.5 centistokes, and the viscosity at -40 has to be less than 1800 centistokes. For reference, 1800 centistokes doesn't mean much to me normally. So I went and looked it up. Honey at room temperature pours at about 2200 centistokes. So it's approaching the viscosity of honey. So at -40 degrees C or -40 F, same thing, it's not going to flow very well. So a car with ABS won't work using a fluid that's that thick in low temperatures. So if you live in Montreal, maybe you don't run racing brake fluid, which may not meet these numbers in wintertime. Okay. So all this other stuff, if you want to know more about it, ask later on if we come across, have enough time, because I did find all the specs on the brake stuff, on the brake fluid requirements, and I can talk for hours on it if allowed to do so. But it's painful for 99% of the world. So
someone did ask about endurance pads versus sprint pads.
Oh yeah. The thing about endurance pads, I'll keep that in mind, Mark. I'll bring that up in a couple slides here real quick.
Okay.
So brake fluid .3, you'll notice it kind of curves down a little bit earlier on in the as the as the moisture content increases, the boiling point drops pretty quickly. .4 is a little more stable, and .5.1 is similar to the .3, but it actually just has higher limits, simply put. Using friction versus temperature. So many manufacturers have this information out there. Some of them don't. I tend to believe that giving people numbers is sometimes detrimental, because people compare one number to another number from a different manufacturer, and it's all done differently. I mean, this is such an oversimplification of the system. It's hard to explain, because setting up a curve like this is probably 8 variables. So an 8-dimensional graph, which is really tough to show. So it's kind of hard to explain all in one simple deal. But basically, you just choose how much friction the tires can take. Tires stop the car, not the brakes. How much friction you can use depends on grip, the tire, downforce, how heavy the car is, whether the car has ABS, and what the driver likes is probably the biggest part of that whole deal. Over braking the car can be worse than too little. And what does ABS do to it? If you over brake the car with ABS, Jim cringes when I say this, but you can get into the hard pedal or panic mode or ice mode, which is not the proper term, but it's kind of the street slang for it, where you go sliding through the intersection with your foot on the brakes in the wintertime and the car just keeps rolling. So if you put too much friction in, it can do that. So it's not always beneficial to go to the highest friction option. It's generally pick and choose. And I make a note there, no two manufacturers use the same exact procedures for dyno testing. So choose carefully and ask questions, whether it's from me or from Mark or Jim or your buddies who are running certain pads. If they work, I wouldn't jump too far up or down the curve, friction level wise, compared to what people around you are running. So on the curves, I want to point out temperature ranges that pads operate in. This is a particular small bore race car series that you can see the front temperatures, the front brake temperature range is up in the 350 to 650 Celsius range. And it's pretty flat curve through that range. So that means the brake bias isn't going to change dramatically during the braking zone. And the rear is also coming up about the same rate. And similarly showing the difference. And in both cases, it's probably a 5% change in friction increasing all the way through braking zone, which actually means that the brake bias isn't migrating much at all. It's probably migrating 1 to 2% in the braking zone itself. So choosing pads that are complementary is really a big part of this process. You don't just pick one because it looks good for the front and a different one because it looks like it'll work better for the back. You have to figure out the system needs, not just that axle. It doesn't exist in a vacuum. So,
all right, Ian, right now we're getting a question here. Maybe it kind of goes to where you're addressing. Is there a rule of thumb of matching brake compounds, tire compounds with the amount of available grip?
Yes. With the advent of all these chunk car, AER, WRL, all these sort of street car based race series, anything that's above, say, a 0.5 mu coefficient of friction is generally not going to work all that well, in my experience. Simply because the more aggressive you get with the compound, the less easily the brake pad modulates. So as you come off a locked tire, because you don't have that much grip to begin with, if you lose 5 or 10% of your friction, suddenly you've lost a lot. And being able to come off the pedal quickly and having it work effectively is really a big part of that. The more aggressive the compounds, typically, and this is across the whole industry, I feel it's safe to say, the less modulation reacts to the pedal. So you can stand on it to get the car to stop, but you have to lose a lot of pressure to get a locked tire back rolling. And Mark can back me up or tell me I'm an idiot. But the more aggressive the compound, the tougher it is to modulate, typically.
Don't worry, Ian, you're not an idiot.
Definitely not. Mark, real quick, before we jump into that, I want to do this. I want to interject 2 questions so you both can kind of help answer this one. Do pad friction levels always correlate to rotor wear? For example, higher mu pads result in higher rotor wear. And the other question, and Lyle wanted to know, was for track day drivers, how can poor braking techniques exasperate issues during a session? So I think you guys are headed in that direction, but can you address that a little bit more to those points?
Yeah, I can address Lyle's question. To answer this question, yes, poor braking technique can make issues worse during a session. And poor braking techniques can make everything worse on track. So that's the first rule of thumb. And anytime you have a technique and you don't modulate properly, let's say if you have a car that is low grip, like street tires on a track surface in an ABS car, and you're using too much brake pressure and you're just getting immediately into ABS mode all the time, you have to obviously make adjustments to meet the car halfway. You know, if the car's not decelerating the way it needs to be, then you are the only thing that you can do. You can change at that moment to adjust for that. A lot of people will brake conservatively at first, and the closer they get to the corner, realize, okay, I need more brake pressure, and add a bunch of brake pressure, and then need to turn into the corner. That is one of the biggest issues with improper braking technique for just about any situation. So you really need to find your proper brake technique early, and make adjustments from there, and then you can fine tune. What I typically, when I go to tracks and I coach, or I do engineering, or I work on cars to make them better, there's not much setup changes or magic changes that I can do to a car to fix a poor braking technique. You know, you're just trying to do everything that is making the car unhappy. It's never going to work in your favor. So the first thing you need to do is make sure you have the right technique. We oftentimes use data acquisition to look at brake pressures and how your brake release is in relation to when you start turning, and what's that doing to the dynamic of the car and how that handles corner entry, and what brake release does mid-corner and through the corner. So if you're in a situation where you're not using proper brake technique, you're always going to have an ill handling car, almost guaranteed. You're probably also not doing the brake system many favors as well. So what that does to make it worse, I mean, if you just think about it, you're always putting more and more brake pressure, or need for the ABS to really intervene more and more and more, or you're creating lockups if you in a non-ABS car in places that you don't need lockups, then you're going to continually have more tire wear, more brake fade, you know, more ill handling car as tire temps get up, and the lack of grip. You know, you start to degrade enough grip to actually make the car work or bail you out of situations. So certainly that definitely exacerbates issues during a session.
Yeah, and maybe to add to that, so let's take the track day guy. You know, 20 years ago, maybe the car didn't have ABS. So his warning of bad braking would be a locked tire, right? So everybody hears a locked tire. What do? They pull off the pedal, they panic, right? Then they got to drive through it. But with the modern day ABS, the ABS has gotten better, and we'll get into that later. We actually have a whole section on ABS. Part of the problem is now the drivers become lazy, and that track day guy is just going to hang on the pedal. He's like, well, guess what? ABS doing its work. I'm going to turn the wheel, and I'm just happy. The reality, though, is now that brake pad's taking all that abuse. That rotor's taking all that abuse, because in the past, driver would pull up. Now he doesn't. So he's more worried about the steering line than he is about the brake pedal.
Yeah, and we will get to this later for sure, because I know there's a whole section on this. So sit tight on that. But yeah, definitely something that I've experienced on non-ABS into, you know, a typical street car ABS, and then into the motorsports spec ABSs that we run in GT cars.
Yeah, so Jeff, the other question was about the more aggressive pads and wear rates. It's going to be there. So yeah, kind of the analogy is I've got a 90 grit sandpaper versus 120 grit sandpaper. That 90 grit sandpaper is going to wear out more. So in general, as a rule of thumb within the industry, a more aggressive pad is going to be more aggressive on the rotor. It's going to wear out some components faster. There may be some exceptions within the rule, but general rule of thumb, I want a more aggressive pad. You're going to go through more equipment. You're going to go through some more things, and you're also going to build up more heat. And most people don't realize that. That goes back to Ian's discussion about the brake fluid. When you have more friction availability, you create more heat. It's got to go somewhere. And so now that fluid becomes another important part of that discussion as well.
Well, real quick, gentlemen, we got about 6 minutes left in this session, and Ian, I want to give it all to you right at the moment, so you get through your presentation if we can, because yep, I think you can see we've got a lot of interested folks out there, and this is as I opened with, this is a very important part of every racer's toolbox right now. If they can go fast, they still got to get it woed down to get it around the corner.
Yep, definitely. All right, I'll jump in. Bite is a term that most of the racers, most of the brake industry talks about. and that is the initial response to pedal effort. So high bite is when Mark puts his foot on the pedal, the car stands on the nose before he even has the pedal to the floor. So generally, more downforce and more grip means you can use higher bite. The lighter the car or the lower the grip, the less bite you can afford. And big heavy cars, like street cars, for example, being used on racetrack, front engine, rear drive, which we know quite a few of those. Generally speaking, high bite will trigger the ABS because it can actually, the driver can actually hit the pedal faster than the weight can manage, can move from the rear to the front, if you will. So it actually precede the load transfer in the braking zone, triggering the ABS before it ever even gets to a steady state.
Mhm.
So this is where I was going to talk about the endurance versus sprint pads. Certain cars, the more downforce they have, the more rear wing they have, for example. A degressive in-stop behavior where at high speeds where things are cool, it can brake harder early in the braking zone, and then as it gets closer to turning, it'll trail off a little bit. This is pretty common for a rear engine sports car with a rear wing, for example, because you don't want it to become unstable on turn entry. A flat plot is pretty common for the endurance pads. The problem is, and Mark will attest to this, that if you are running endurance pad and you start running it harder than maybe ideal, you might start running into this part of the curve where it's actually fading. And progressive in-stop tend to be more along the lines of a sprint pad because you've got to keep the friction all the way up, and it's going to wear out faster, but you absolutely have to have it working up at the 700 to 800 Celsius or 1300 glowing red hot at Martinsville, prime example. So those are the quick, endurance rear, endurance front, typically from left to right, and then progressive would be the front pad for a short track or a sprint car. Talking about pad wear, endurance pads are going to wear a little longer, but they have to stay cooler. They operate in a cooler temperature range than a sprint pad will. So keeping them in the right temperature range with the right cooling package is key. Sprint pads, you can run them as hot as you need to, but the life is going to be shortened. Rotor life, I think we talked about that a minute ago. Selecting it depending on what you're running. Is it chunk car, 12, 24-hour race, whatever, or a 1-hour sprint? Pick and choose what you want. Does it affect the disc life? Pad thermal conductivity is one I'm going to talk about for quickly, but the more ceramic content in the friction compound itself can generally insulate the caliper body. A lot of street cars have a 16 to 17 millimeter thick pad with the back plate pushed up all the way up against the caliper body on the inside. So a lot of times the street cars are where the thermal conductivity becomes a real issue. For racing use, racing calipers tend to have a 5 millimeter air gap between the back plate and the caliper body, which helps insulate everything, keeps temperature away from the brake fluid. And that's really what that's for. So for street use, street calipers, OEM stuff, there are options to high metallic compounds out there. If you have a high-end car with the ceramic brake discs, Porsche, Ferrari, Lamborghini, Bugatti, all the top end, there are basically two different styles of discs out there on the market. There's a CCM, which, in our catalog, we talk about there's different pads for different specific disc types. The CCM disc actually kind of looks like chopped fiberglass mat. Like you cut the bodywork on the car and it kind of looks like it's got all the fiberglass cut in there. The CCB, if you machined off that crackle surface, almost call it a crackle glaze, it'll look like the CCM. But that difference in material on the surface is just an anti-wear coating. So below that coating, it looks the same. So if you ever overdo it on the pads, or put the wrong pads on the wrong disc, it can strip that coating off and basically cost you about $4,000 per corner, I think, the OEM price for those.
Or more.
Or more. So,
keep your feet off the brake.
Yeah. Well, be careful with what you put on it is what it comes down to. And I've had a lot of questions asking about, do they wear out faster using racing brake pads? Yes, they do. Bottom line. The only way to measure wear on these, as long as they look dimensionally correct and haven't cracked or failed, is by weight. You have to wash them, strip them off the bell, dry them off thoroughly, and weigh it on a scale to determine how much of the carbon fibers that form a lot of the structure have oxidized away. And in racing or in track use, it's going to operate at a higher temperature, causing that oxidation to happen faster. So you can be safer on the brakes by using a racing pad, but you're also going to accelerate the wear of the disc a little bit. So just there. I like the 3-color brake rotor paint stuff that you see here, because even I can figure it out real quick. It's green, keep going, you're doing great. You've got things bedded in probably. If you got it to that temperature range, you've got it bedded in. Orange, start paying attention, just like a street light. And red, you've either gone too far or you need to look at a different friction material, different compound. So those are I prefer that over the single color where you read the color shade chart, because I can't, apparently my sensitivity to color isn't very good. So ask my ex-wife about colors in the house. But that's kind of the key, is keeping an eye on the disc temps is a big part of the program. Caliper temperatures, if you're running an OEM caliper, and if you've ever had brake fluid fade, start paying more attention to it, and on top of that, if you ever boil the brake fluid in the caliper, you should absolutely rebuild the calipers, because the seals are going to be toast by then. So I'm going to hand it over to Jim real quick, because he's the ABS guru of the group, and just, I guess, tell me to go.
No, we got it. So, and we'll have Mark interject here as well. So there's a couple things, right? So the ABS industry has changed a lot. So you got to know what's going on. And a lot of people think it's black magic. There's great engineers in the IMSA paddock and the SRO paddock, and there's knowledgeable companies out there. But for the general person, the general public, go to SAE. There's a handbook. There's the Bosch Automotive Handbook. For edition 9, there's pages of information available on ABS technology, how it works, and that attracts that's really for the track day guy. That person that's got a Gen 5, Gen 6 Camaro, C7, C8, you actually can get some information. There's all kinds of information there that's available. Go to the next page, Ian. Within the industry, there's 3 key players, right? So that's what you need to know. Within these companies, there's a ton of expertise. They know what they're doing. They're the experts. You got development engineers, software engineers. They work very closely to develop solutions for all the major car manufacturers. In the States, the big 3, right? So GM, Ford, Chrysler. Then you got your Toyota, Honda. There is a lot of development that goes on in the ABS industry as a whole. So the ABS itself, there's a whole control theory. On the left-hand side, just a basic graph. We call it a mu slip curve. So this really is, how does the tire interface with the road? Back to what Ian said earlier, the brakes don't stop the car, the tires do. Well, the tires are going to stop only if the surface is there. So in the ABS control theory, the ABS has to recognize what surface it's on. It has to know if it's a good asphalt road, if it's a concrete road, if it's a gravel road, it's a wet road. All those surfaces have different tractive forces. And so you have to be able to model that or develop that into the algorithms. So in the end, right, when you're in that part of the world, the ABS calibration engineers, they develop safety systems, right? That's when you buy a car off the lot from your dealership, that's what it's made for. In the end, what that system's made to do, it's to optimize the stopping distance. And it's also important to have some steering ability. So I'd be able to steer through that condition. And overall, the calibration engineers and the engineers involved in the programs, They develop it around the OEM solutions in the race in the production world. In the aftermarket world, there's all kinds of things that people want to do, right? So I want to do a better tire. I want to do a better calibration point. So what they're looking for is, or calibration point, different brake pad. When you upgrade pads and rotors and also the tires, you're changing the characteristic of what that ABS was developed for originally. And most people don't understand that. They just say, I just put on a better tire, it's got to be better. In some cases, for the racetrack customer, that track day guy, you may have added some additional factors you didn't think about.
Gentlemen, I'll be honest with you right now. This has just been unbelievably informative and educational, and we've run out of time, honestly. and this is one of those times I'm going to have to defer to Francis to hopefully come back on and give me a direction here, because I feel like, we've got another 30 minutes to an hour that we could talk about this stuff. So Francis, what do I do?
Okay.
I mean, all of a sudden I'm in over my head right now and understanding. I want to know more.
So
what do we need to do?
What we'll do, Jim, is we had the same situation with Rottler a couple months back, is we'll invite you back for a part 2, because I feel there is so much more to be talking about. We know people are busy, have a lot of things going on. We try to do those webinars within an hour. And so really what I'd like to do is invite you to do a part 2. So we'll carry on where we left. There's plenty of questions haven't been answered too. So it was a fascinating webinar. Thank you so much for your time, your preparation, your dedication. We learned so much, and I think that's probably the best thing. So let's get in touch after, Jim, and then we'll look at the calendar, and then we'll do a part 2, and we'll get you guys back on.
And I want to do it because I got questions from Mark and Jim, as well as I want to hear more from Ian, because y'all bring up so many interesting dilemmas that I ran into as a crew chief, but I see there's opportunities to address stuff, and especially with Mark's ability to bring people into his simulations, and you can find out what a driver's doing sometimes, between different things. I mean, there's just so much out there. Okay. As we started this whole deal,
absolutely,
we want to go fast, but we got to be able to stop it right.
Absolutely. So let's we'll coordinate. We'll organize a part 2, and before we close, Judy, do you want to tell us who's next week, because we have something special too?
So we actually have our first professional top race team going to be on. That's Connie Coletta Motorsports, and their topic is creating and maintaining a sponsor satisfaction. So we're going to have the team manager on, who's Bob Lawson, DHL America, Dave Jones, and then we have Stanley Black & Decker, which is Mac Tools, Tony Merritt, and it's going to be very interesting. Tony Merritt does a lot of different sports, football, basketball, just everything, and they're making time to do this next Wednesday.
Perfect. Very good. So
I want to say one last thing, gentlemen. Great job. Seriously. A lot of great information. I just want you to know that we just kind of like we peel back that first layer, and I think you see there's a lot of interest in what you're offering up.
It's hard being engineers sometimes. We got a lot to tell you, and that's why we need Mark here to keep us in line, and Jeff, we need the 2 of you to fix us next time.
Yeah.
Well, I'm up for it, because again, I've enjoyed the education. Thank you.
Very good. And then we put your products on the homepage of EPARTRADE again. So if you have any questions, go to EPARTRADE.com, click on PAGID's product. You can connect with the team at PAGID directly and ask questions. And so the webinar has been recorded. It will be posted on the EPARTRADE platform later on today. And then we look forward to seeing you next week. And then for the next part 2 of PAGIDs and brakes. Thank you very much. Have a great week.
Thank you, everybody.
Bye,
Have a good day.